Allie. I work for a nonprofit organization called Learning Undefeated. We provide life-changing STEM education and career opportunities to underserved communities. Today, for our at-home science activity, we're going to dive into the world of waves. Now, when you probably think of a wave, you think of a squiggly line with peaks and valleys that we oftentimes call crests or troughs or compressions and rarefactions. But have you ever stopped to think of what the motion of a wave looks like? Today, we're going to make our very own wave machines. For today's at-home science activity, you will need a few materials. 2 cans of soup, or you can use 2 glasses. A bag of mini marshmallows, Skittles, or gummies. Toothpicks, and some form of tape. Once we have all of our materials, we can start building our wave machine. The first step to build our wave machine, you'll need to lay out a pile of marshmallows, Skittles, or gummies, either kind, and a bunch of toothpicks. And what we're going to do is we're going to stick a marshmallow on each end of the toothpick like this. And we're going to make about 25 to 30 of these. Next, we are going to take 1 can of soup and we're going to place it at the far end of our table. So you can see over here. You might want to add a few pieces of tape just to hold down your soup. That should hold it. And then we're going to want to use our other can of soup and we're going to place it at the other end of the table here. So I'll show you guys here. And you're going to want to put some tape on that as well, just to hold it. Once you have your soups or your glasses in place, now we can assemble our wave machine. What you're going to do is take a piece of tape. Again, it can be any type. I'm running low on scotch, so I'm going to use this tape. And you're going to put it so that the sticky side faces up. And we're going to, I like to loop it kind of upside down so I can click it to the side of the can. Go from one back of the can. You're going to drag your tape across here, all the way to the other side, and tape it on the other side. Remember, the sticky side goes up. And we're going to go just like that. Once your tape is on, I'm going to take a few extra pieces of tape and just put it across the tape so it doesn't come off the can here. And again, if you're using glasses, you might want to add ice or water just to weigh down your glasses a bit. So now we have a piece of tape running from each of our soup cans. So what you're going to do next is you're going to take your marshmallow toothpicks here, and we're going to place them. You want to center it on your tape. And you want to keep about a ½ inch between each toothpick, so the marshmallows should almost be touching. All right, so when you're done, it should look like this with all of your marshmallows and your toothpicks across. You want to try and make this tape as straight as can be and make sure you have enough tape holding your 2 soup cans so that they don't cave forward. Now that we've assembled our wave machine, let's think a little bit about waves. A wave is a transfer of energy from a medium from one point to another. By lifting up one of the marshmallows, you're causing a vibration that sends a disturbance from one marshmallow to the tape all the way down the line. This vibration is transferring energy. Some properties of a wave include amplitude, frequency, and wavelength. In a transverse wave, the crests and troughs are the locations of maximum displacement of a particle up or down on the wave itself. Amplitude is the maximum displacement of the particle on the medium from its resting position, or its highest point. In longitudinal waves, such as sound waves, amplitude is represented by the loudness of the sound. We can change the amplitude of a wave by lifting the marshmallow higher or lower. Wavelength is the length of one complete cycle. We can measure this by going from crest to crest, or even trough to trough. Frequency is the number of waves that pass in a given amount of time. If we were to measure one wave cycle, so wavelength, from crest to crest, and we were to count that one cycle, we could then count the remaining waves in that same given amount of time. For example, if we have 3 waves in 1 second, our frequency would be 3. We can change the wavelength and frequency of a wave by jiggling the marshmallow a few times. You'll notice that each wavelength is shorter and the frequency is either higher or lower. So now if we do it slower, you'll notice the change in the wavelength and the frequency. So now that we've learned a few things about waves, now you can play with your wave machine. You can test out different things by removing marshmallows. Let's just take a whole bunch of them off there. And seeing if it changes the speed. Or you can just alter your amplitude, frequency, or wavelength. For more at-home science experiments, visit learningundefeated.org/at-home science. See you next time.